Welcome to today's webinar, Cost-Optimized HMI and Advanced GUIs for Automotive and Transportation Applications, brought to you by Tech Online, NXP, and broadcast by AspenCore. Discussing today's topic are Phil Pessis, Technical Product Marketing Engineer, NXP Semiconductor. Phil is a product marketing professional with almost 20 years of experience with a strong understanding of ADAS systems. He is responsible for the product marketing and go-to-market plans for processors and microcontrollers targeted for the automotive and distribution markets. And joining him today is Johan Lopez, Technical Product Manager, the QT Company. Johan has more than 10 years of experience working with the QT Company to help engineers create HMIs for various platforms, including embedded, desktop, mobile, and connected devices. He is the product owner of QT for MCUs and is responsible for its vision and roadmap. It's with great pleasure I now turn this special session over to Phil to begin. Phil, take it away.
Thanks, Chris. Thank you guys for joining today. We'll be going through some of this agenda here today. Basically, we'll start with the introduction. I'll talk through the i.MX RT1170 crossover product line. I'll talk through some of the features and benefits of this family and what it offers. And then we'll transition to kind of a general enablement and training section. And then we'll talk, that'll kind of be a transition to the availability in QT for MCU portion. And then we'll wrap up with a live demo. Okay, so with that, Johan?
Hi, thanks, Phil. So I'll give first a brief introduction of QT and the QT Company for anybody who might not be familiar with who we are. QT is an application development framework mainly known for its graphics capabilities, and it's not a new technology. It's been around for more than 25 years. The first public release was back in 1995, and over the years it has grown in popularity, and we estimate that today there are more than 1.5 million developers across the world. And the QT Company is the company driving the roadmap and the development of the QT framework. It's an international company with more than 400 employees across the globe, and we have more than 3,500 commercial customers across 17 industries. You can see some of our reference customers here in this slide. There are some well-known names, and something we're really striving for is making sure we can create the best product for all of our customers, even though they come from very different industries with very different needs. And I'm quite happy to say that according to the latest survey, 95% of our customers say that their expectations are exceeded with Qt, and 80% of them are saying that they're more productive with Qt than they were with other GUI tools. A few words also on I misclicked, I think, on the market that Qt covers, because as you have seen from the reference customers, these are very varied, and Qt originally was really well, and still is, well known for desktop application, like creating application for Windows, Linux, and Mac. But it's been years now that the QT Company has been putting a lot of effort on making Qt a great framework for embedded systems as well. And today there are thousands, really, of devices on the market for the automotive, consumer electronics, industrial automation, and medical markets. And I think we can say really that today, especially for embedded Linux system, Qt has become almost a de facto standard for graphical user interface. So back to you, Phil.
So with this introduction of the i.MX RT1170 crossover line, this family represents something as pretty big advancement in the automotive processing lineup, because a lot of our last generation or even current generation processors range from 100 to 200, maybe even 300 megahertz per core. So you can see with this i.MX RT1170, the primary core, the M7 ARM Cortex core, runs up to 800 megahertz max frequency for the automotive device, and then it even goes even higher, up to 1 gigahertz for the commercial available version. In addition to that, it also has a secondary core, an ARM Cortex M4 core that runs up to 400 megahertz. So this represents, you know, in some cases 2, 3, 4x the performance of our current generation, or, you know, currently on the market automotive processors. So, you know, this is a big amount of performance and throughput that helps open up automotive applications into additional capabilities that are not available today on a single chip, but would take, you know, 2 or 3 different chips to accomplish. So on this i.MX RT1170 family, we've got a ton of features packed into this microcontroller. It has 2 megabytes of internal SRAM. We've got a 2D GPU and accelerator built in to handle all that graphics and HMI performance to help with clusters and displays and cameras. We've got 2 gigabit Ethernet ports. You know, we've got one for audio-video bridging and one for TSN or time-sensitive networking. It's built on 28 FDSOI technology. So this is going to enable great power to performance ratio. So it is optimized for both active power and leakage power to minimize those. And then it also, the last piece here is on advanced security. We've got a lot of built-in encryption and decryption capabilities into this RT lineup. The markets it serves is IoT, industrial and commercial. We've got industrial, factory automation, power and energy. And then in the automotive space, which we're talking about today, it's that in-vehicle HMI interface where you need a small display, as well as into the cluster or dash on a maybe any type of mobility solution or transportation solution. So the target applications, once again, for the automotive transportation, some of the attributes I wanted to point out. What's unique about the RT1170 in comparison with the other i.MX RT products that came before it is that it is automotive qualified. This device did go through the AEC Q100 testing. It is ISO 26262 qualified to the quality managed process. So you have that intrinsic safety and security attribute that's typical in all automotive quality and applications going into this space. So I mentioned before that there is a slight degrade in the performance of the max frequencies of gigahertz, but for the automotive qualified in this family, it's going to range from 600 to 800 megahertz, depending on what you enable and for max performance. The M4 core is still going to run at that 400 megahertz. But some of the connectivity we have CAN FD, or flexible data rate CAN. I mentioned the gigabit Ethernet ports before, and then another major value proposition to customers is that we did include this family in our 15-year longevity program. That's part of NXP.com's commitment to supply assurance. So this part will be around for a minimum of 15 years and typically much, much longer. It does also support a parallel LCD display. The max frequency is up to the WXGA resolution of 1280 by 800. It does have the MIPI interfaces for the graphics, cameras, and HMI that I mentioned earlier, as well as that advanced encryption protection. So on this particular block diagram, a few of the things, I'm not going to go through every feature, but what I want to call out are some of the things that makes this RT1170 kind of special, and where it fits in, where it blurs the line between a traditional microcontroller running at 200 megahertz, for instance, which was very typical in the last couple of years, with application processors running at a gigahertz frequency with multi-core. So typical of a microcontroller is that you'd have CAN, LIN, SPI, and other type of connectivity. This RT1170 offers 3 CAN FD or flexible data rate CAN modules. You've got the 2 gigabit Ethernet ports I mentioned earlier, one for AVB, one for TSN. A third Ethernet port is available. It meets the IEEE 1588, and it supports 10100 speeds. The other piece is right below the cores. You got that primary core, ARM Cortex M7 core. That's your high-speed core. It does have all the tightly coupled memory and ECC protection on the memory. The secondary core is that ARM Cortex-M4 core running at 400 with the parity checking for data instruction, as well as the tightly coupled memory that also supports ECC memory. Right below those cores is the multimedia, and that is really what makes this part particularly useful in low-cost HMI. It has that 2D GPU I mentioned earlier with acceleration. It supports a 2D PXP module, as well as a MIPI CSI port for camera, two different types of camera, a MIPI port and a parallel port, and then a MIPI in parallel for the output to displays. Then you can see on the icons to the right, it's talking at the top right, we say it's built for automotive and automotive qualified. It also addresses motor control. And the next thing I wanted to point out was the Flex PWM modules. This device has all the same attributes and functionality and features that are part of the i.MX RT1150 design, where we have great demos showcasing that you can run full LDC or PMSM LC control motors simultaneously. This part has the performance and the peripherals, such as that Flex Precision PWM control, to handle that type of requirements running in parallel. And then the last block to point out is that hefty security module that allows on-the-fly encryption, decryption, and secure boot. So on this RT1170 table, you can see that we offer 4 different versions of the RT1170 for automotive, and that is the 1171, the 1172, the 1175, and the 1176. So what this does is it offers you the ability, or the customers, to decide what features are important, because there's so many features in this device that they can choose either a full-featured superset, such as the 1176, that has all the functionality, in addition to the TSN capability. That's the main difference between the 1175 or the 1172 and the 1176, is that you get that TSN, or time-sensitive networking capability, on that second gigabit Ethernet port. The unique thing I mentioned earlier is that these are all quality managed to the ISO 26262 safety standard for automotive. The reason for the 2 different speeds is, like I mentioned earlier, there's a gigahertz speed for commercial and then 800 megahertz for automotive and industrial. It's important to point out that we do have an internal DC-DC control. So, depending on where you want to set that voltage, you'll get a varying level of performance that you can decide on. That second core is at 400 megahertz, and then the other functionality is that MIPI CSI DSI options, options for with or without the 2D GPU. If you don't need that and you want to take advantage of a lower power consumption, you can take advantage of that with that option. And then it comes in the 289 MAT VGA package across the entire family. And then you can see there below we have the temperature ranges for the automotive devices, as well as the production part numbers listed in bold. On the enablement side, the platform our default platform is the RT1170 EVK, or evaluation kit. This board, supports all the connectivity that's available on the chip on the superset device. It does have JTAG interface for debugging, as well as an onboard DAP link debugger. And then it also has some, other NXP content for, multi-axis accelerometers and compass. And then you can see down at the bottom right, we also include a 5.5-inch LCD display. It's only $79. You can purchase that, and it plugs right into this EVK board. And on the training side, we've got a lot of training already available out on the NXP.com on the RT1170 page. We've got over 5 different training blocks for the graphics. We've got memory management training, power management, debug and development tool. There's even a getting started page where you can click through how to get the board unboxed and loading the software, and walks you through that. And then if you're not familiar with time-sensitive networking, there's additional trainings there that you can go through. It's all self-paced, and you can go through but there's a lot of content out there to support you. And then there's even an i.MX community out on NXP.com that you can explore. Okay, as far as, when we launch this device, we have a lot of partners, and they're kind of grouped in these categories. So the ecosystem includes all wired and wireless connectivity. So on the wireless side, we've got Wi-Fi modules and partners there that you can plug in. We've got wired solutions around the time system networking and CAN flexible data rate. And then on the graphics side, QT is a great partner. There's additional partners with different capabilities and software solutions for around graphics and HMI. And then on the automotive side, I will speak to this in a little bit, but we have AUTOSAR software to allow you to go into production with a safety certified software package. We do have OS partners, as well as cloud services, AI/ML, or machine learning solutions, leveraging all the on-chip resources that the i.MX RT1170 offers. We've got that security solution on chip, as well as there's some security partners that if you need, even more capabilities, you can use one of our partners. And then we've got the device programming, development tools, hardware, and maker boards covered. And all this you can find on NXP.com on the RT1170 webpage. So the development environment for RT1170 is the MCU Expresso IDE. So inside MCU Expresso, you'll find the SDK or software development kit that supports RT1170's multiple different configurations and part numbers. Also inside there, you'll have linkers or plugins for all the premium tool chains you might be using. If you're not using MCU Expresso, we've got partners plugins that are available. And then inside it, there's a couple pieces that are really valuable, and that's we have a configuration tool. You've got device and peripheral configuration of all the different on-chip resources that we offer. And then we also give away a free data or debug visualization and control tool called FreeMaster. So earlier I mentioned the AUTOSAR MCAL support. So we do have an AUTOSAR MCAL package. The beta version is available today for our i.MX RT1170. You order that, you can get access and get the software within 1 week. And then once you get that beta package, our team's going to work on getting that RTM package built for you within 2 to 3 weeks after you receive the beta. It does require a license, so to get the MCAL package, that gives you all that safety low-level driver compliance to the ISO standard, it will require an NRE to get that license. But the message is that if you need safety software, we've got the solution for you with the AUTOSAR MCAL package. It does support the M4 and M7 cores. It is compliant to the latest standards. It is quality managed. And then if you need ASIL B, we even have that if you're going to combine the RT1170 with an ASIL B compliant solution such as S32K, 11X. You've got ASIL B capability on that microcontroller, so you can combine these two and have a graphic safety solution built together that reaches ASIL B. We do test our MCAL packages. They run from RAM and they're targeted on the Green Hills compiler. They're tested on Electrobit's Tresso Studios config tool, and then they're integrated in our Linux, BSP, QNX, and Vector Cantech communication stacks. There are 3 different project types, depending on what, if it's a single project, multiple product line licenses, and then we also have multiple family pack licenses. And in summary, just to wrap up, this family is something unique and different for the lineup in our automotive processing group. A lot of our single chip or single core or dual core solutions have been 200 or 300 megahertz per core. So this is a significant boost in performance. It also offers that graphics or HMI capability that's not widely popular on a lot of other devices. And then you've got a lot of communication and high-speed connectivity, such as those multiple gigabit Ethernet ports. You've got that on-chip security, so you don't have to worry about any kind of hacking or warranty claims. You can use the security to your advantage there. And then finally, I'll point you to our website, nxp.com/i.MX RT1170, for all the access to more information, all that training I mentioned, as well as all of our partner solutions.
So yeah, my next part now will be made of two different parts. I'll give you a live demo in a moment, showing you how you can create or do rapid prototyping with Qt on the i.MX RT1170. But before that, I wanted to highlight a few points on how both basically the RT1170 and Qt can really help to drive down costs here, specifically in the automotive applications. And for that, I wanted first to show you this picture. I don't know if your car looks like this, at least mine doesn't, but there's something interesting here, because I think this is how more and more all of our cars will look like. And what's specific is the number of screens that you can see are pretty much everywhere. And again, this is becoming more and more common. It used to be specific to premium and luxury vehicles up to this point, but actually now, because of the i.MX RT1170 platform, which is quite unique really from a capabilities point of view, and at this price point, it's now possible to create a very advanced with touchscreen applications for applications which were previously not possible at this price, like for example the digital instrument cluster or the HVAC control, like the e-mirrors and so on. But there are different challenges, of course, in any case with the software specifically, because even though it's possible to create all these different systems now at a lower cost, the development of the software itself can be challenging, because typically you would have multiple hardware platforms. For example, with NXP, you might use any of the i.MX RT1170 or i.MX 6 or 7 or 8 for any of these systems. And also you might use different operating systems. Could be a real-time operating system, Linux, Android, or anything else really. So where Qt can help here is that we basically support all these hardware platforms and all these operating systems. So it means that you can reuse your GUI code, but also skills across all these systems. And it's not just the embedded system. I wanted also to briefly mention that it's also mobile, because this is becoming increasingly common as well for cars to have a mobile companion. And this can also be done with Qt, as Qt supports Android and iOS as well as a target. So now focusing a bit on Qt on the i.MX RT1170. For those of you who already know a bit about Qt, I want to emphasize here that Qt on the i.MX RT1170 is a bit different. It's a different product that we call Qt for MCUs, which is essentially we took what makes the core of Qt, the technology called Qt Quick, and the QML language, which is our own language to describe user interfaces. And we have created a completely new runtime, which is much smaller than what you would typically use on desktop or even embedded Linux. So it's very tiny. It's the minimal requirement from a RAM perspective is around 80 kilobytes of RAM. And to be able to achieve that, it's also about assets, because typically for graphical application, assets are what really use most of the memory. So we have tools to optimize all the graphical assets and the fonts so that your application is as small as possible and also as fast as possible. And this product, Qt for MCU, is as I already said, available fully on the i.MX RT1170. What's really interesting, I think, about this hardware platform is that it's, as far as I can tell, maybe the first platform to bring some very advanced graphics capabilities, which up to this point were reserved or specific or common only on mid-range or high-end SoCs, typically Cortex-A based. But on the RT1170, as Phil already mentioned, you have a really capable GPU, which can handle vector graphics. You can do also 2.5D, which is basically applying 3D transformation on 2D objects. And there is even more. So with Qt for MCUs, you're sure basically to be able to use all these advanced features of the 1170 as we have basically all these features available in our product. And to help you really create your application as fast as possible, we really want you to focus on creating the user experience rather than implementing graphics. Qt for MCU comes with more than 40 ready-made components, as well as 4 reference demos covering different use cases, including automotive use cases, and 18 examples for all the key features of the technology. Now on to the workflow, because this is a really, I think, important aspect of Qt. What we want to do is really to reconcile 2 different types of people who, at least in the past, have not been working, let's say, very well together. And these are designers and developers. They speak different language, they work with different tools, and you might know that it's often an issue to implement a UI the way that designers really meant it to be. We really want to solve this problem by providing tools for each type of person here, which can help them solve their own specific problem while, again, all working together with the same technology. So we have Design Studio, which is for designers, and Qt Creator, which is for developers. And with Design Studio, designers can really focus on creating great-looking UIs, which they can prototype quickly and even try already in the design phase directly on the target hardware. While with Qt Creator, developers can focus on the backend, on the integration, but not, spending days or months on just implementing specific graphic components. So now I will show you how you can, I'll have a brief demo on showing you how you can create a simple graphical user interface with Qt and how you can run this on the RT1170. So before I start with the tools, I wanted to show you also what you need to install to make sure you can do this yourself. In the Qt installer, make sure you go into the Qt for MCU section, which is what you will need for the RT1170. You can select the desktop component if you want to try it on desktop as well for prototyping, and then the NXP i.MX RT1170 package. And if you don't already have all the necessary tools for building, we provide these as well in our installer. You will need the ARM GCC compiler, the NXP MCU Espresso 1170 SDK, as well as the NXP MCU Espresso IDE. So all of these, you can download them directly from NXP website as well, but here you have the complete solution available here. Select this package, click next, and everything you need will be installed. Once that's done, you will have the 2 tools I just mentioned in the previous slide. Qt Design Studio first. So Design Studio is the tool you see now here. This is the tool for designers mainly, where you only have an environment to create graphical user interface. And well, we'll start here by creating a, actually, I wanted also to mention Qt Creator. So this is here the tool for developers. It looks similar, but it has different capabilities. You can do full C and C++ development, as well as GUI development as well in this tool. You have documentation, which is included. Here is the Qt for MCU documentation with a lot of information on what you can do and how to do it. This documentation exists as well online if you prefer that format. And I wanted specifically to show you the RT1170 page, which you will find here under Getting Started on NXP, and then the 1170 page where you can find all the requirements needed to develop for this platform and different instructions on how to build a Qt application for this platform. So back now to Qt Creator. I wanted also to show you that before creating our own application, that there are already pre-made demos that you can run out of the box. If you're not able to create a demo from the beginning, just pick any of the examples or demos readily available from the home screen. In this case, I will select here this motorcycle demo, which has been purpose-built for the RT1170. Once you open it, you will need to select a kit. This is what is here shown on the left. A kit is basically just a configuration to build for a particular platform. So here, just select the i.MX RT1170. The project will open. And really all you need to do is make sure you select here in the target selector the correct target. Then click Run. And it will build and flash also directly on the board if it's connected. And here you can see this demo running on the RT1170 evaluation kit. So really that's all it takes to run your first Qt application. Just our Qt Creator, open our pre-made demos, click Run, and that's it really. But now let's have a look at how you can create your own application. So for that, I'm going to go back into Design Studio to do the GUI design. And I will create a new project. For this, you go in the File menu, click New Project, and make sure you select the Qt for MCUs type of project when targeting the RT1170. Then we just need to set the folder as well as the name for our project. Here, I will just, this is not correct, I need to name it Demo. I think it can have numbers in it. Then you need to select the resolution. 720 by 1280 is the resolution of the evaluation kit display. And now we have here our project. So I would say there's nothing uncommon here. In the middle, you have the preview of how your screen looks like. On the right side, you have the property panel, which lets you configure different properties of your GUI elements. And on the left, the components library. So here I have my default screen with some template code. I don't really care about it, so I will remove the template text. And I want also the background of my screen to be black. So I just click on the rectangle and then go into Properties and change the color to black. Now, the next step would be to actually create content and add different components to it. So you could do this using all the pre-made components we have, but something even better is to use an actual design tool that designers are used to work with. In this case, it's Photoshop, Adobe Photoshop. So I have here a simple screen, which was designed entirely in Photoshop, which is for an infotainment system. And what we provide as part of our tooling is a plugin for Photoshop. It's called Qt Bridge. This is what you see on the right side of the screen here. And well, you can simply export that. And there are some requirements. I'm not going to detail them. You need to organize your Photoshop file using artboards and groups and so on. And if you do this the right way, clicking this export button will create ready-made components. And I'm going to show you this in a moment. But before that, a word also about fonts. You need to add all the fonts required in the design into the project folder. So here I have already some ready-made fonts, which I'm just copying into my project folder. And then I can import the Photoshop design. So for this, on the left side, we have this asset section, and you can click the plus button. And then I go where I did my Photoshop export. You see all the assets here and this special file, a metadata file. Just open that, and you can pick where exactly you want to import all the components. And once that's done, there are a bunch of other options. I'm not going to detail right now, but you click on import, and this is where it's actually going to create code or generate code. As I mentioned earlier, it's QML code. It's Qt own language for GUI. And now you can see on the left all the different assets as well as the components. In addition to the ready-made components, now you see we have these components coming from Photoshop. So I'm just dragging the home screen onto the main screen. I can here in the property pane make sure it's aligned in the middle of our screen. And well, we have already a running application. I mean, it's pretty simple at this point. It's static. It doesn't do anything, but it's already running. So let's make this a bit more interesting now. I have my different components, and here are the buttons. This is, remember, was automatically created from the Photoshop import. It doesn't look exactly right. I mean, it's fully static now. The labels don't look correct. So what I need to do is I need to create two different states, and we have this in Design Studio. I want this button to have two states, one active and one just a base state. The active one would be the state in which the button would be when I'm in that mode, for example, the home screen. So I created two different states, and for each state, I just change the properties of each object so that they are, looking correct for each state. So here now I have my base state with the label showing white, and the active state where the label is a bit bigger but green. Then the next step is, since this is a component, I want to change the label in each instance of the component. So for this, you can use the concept of properties in Design Studio. Each component can have as many properties as you want. It will be the interface of the component. So here I'm creating a property named label. And once that's done, I need to bind it. And this is another concept, important concept of Qt, is the binding. So all I need to do is to bind my property to the text elements that I already had here. So I create a binding, and I just map my component property, which was named label, to the text item text property. And you just need to do that. And whenever the input value changes, my text item will be automatically updated. There's nothing you need to do to handle, dynamic changes. All right, so now we have our component ready. We can go back to the home screen. And you see here we had several instances of our components. Now they're all showing home because that's the default value of our component. So I need to change that. So I click on the second one, and if I go in the property panel, now you see that it has a label property. This is not built in. This is the one I just created. And for each of these buttons, I can now change the label. And you can see it reflected immediately in the preview in the middle. After that's done, we need to handle interaction, and specifically in this case, touch interaction. So what we want is that whenever we click on each button, I want the UI to go into a different mode. So here we can handle these different modes with states again, like the button. So what I'm going to do here is create a state for each mode. So a radio state and aircon state and car info state and so on. Settings is the last of the states. And then I just need to configure each state. So I'm going to have to go through each of them and then make sure I configure each GUI element correctly. So in the base state, I want my home button to be in the active state. Every other one should be in the base state, and so on. And I do this for each mode. So in the radio mode, now it's the radio button which is active, and all the other ones are not active. I do this, a bit repetitive task, but all of these need to be done for each state. Settings is the last one. All right, so now we have our correct configuration for each state, and we just need now to handle actual touch inputs. So for this, we can use the concept of connections. Each object in Qt has signals, which basically notifies that something has happened. In this case, our buttons have a clicked signal, and all I do is that using this connection panel here, I can connect actions to signals. So all I do here is changing the state of my UI based on which button has been clicked. Now, if I run my application, you see it's working as expected. Whenever I click any of the buttons, it highlights the correct mode. Okay, now going to a bit more advanced topic, animation. It's fairly important these days to have good-looking animated UIs. And to illustrate that, I'm going to animate this clock component. I want the clock arms to go around. So I'll just open that component. And to be able to do the animation, there's all animations in Qt Design Studio are based on a timeline, which is common in many design tools, where you use timelines and keyframes. So here, all I want to do is to rotate the hour arm from 0 to 360 degrees. So I'm creating a timeline. You can also set up an animation with the timeline so that it automatically runs through the timeline. And I have now my timeline created. And I just need to select each component I want to animate, and then I can animate any property. Here is the rotation property. So I go at the beginning of an animation, and I insert a keyframe for both images. And then I go at the end of the timeline, and I create another keyframe, which would be 360 degrees. And then Qt will automatically create all the frames in between the keyframes. So now if I move the cursor here, you see that now I have my images being rotated between these two keyframes. And you would need to do the same for the minutes arm, but I skip that part. So now I can run my application again on desktop, and you see we have our animated clock and our interactive buttons. So what do I do now that I have this application? How do I run it on the RT1170? So for that, you need to go into Qt Creator, the tool for developers, and I can just open the exact same project that I had in Design Studio. It's really the same project, and in it, there's this CMake file. So Qt, for instance, uses CMake build system. So just select that CMake file, select the platform you want to build for, in this case, the RT1170. Going to configure the project, pull all the dependencies, configure all the tool chains and the SDKs and so on. There's nothing you need to do. This is all included with Qt. Make sure you select the correct target here. And then same as for the demo earlier, just click run, it will build. It will also flash onto the board. And now showing, you see, show you on the line, we have here the same demo running on the evaluation kit. So it's as simple as that. Really, you have everything you need to do this kind of quick prototyping. I'm not covering in this demo, all the backend development. So this could be, a webinar in itself. There's many to cover here, but here I wanted really to show you how easy it is to create a prototype which can run on the board directly. So hope you enjoy the demo. Here are some useful links to help you do your own demos with Qt. There's a link on where to download Qt. I wanted to mention as well that if you don't already have a license, you can get a free evaluation from this page for a month. There is also a link on different resources with different videos, online documentation, as well as ready-made binaries. If you just want to try one of our demos, you don't want to download the full SDK, go to qt.io, microcontrollers, NXP, and from there you can download the binaries that you can flash directly onto the board.
All right, thank you, gentlemen, for a great presentation. We're going to now move on to the question and answer. So joining us today for our Q&A session will be Arindam Jana, and he is the product director for the QT company. So welcome, Ari, and we're going to go ahead and get started with some questions here for Phil and Ari. First one, is it supported from QT 6 Plus only?
Hey, Chris, I'll take that one. This is Ari here. We are talking about Qt on the NXP RT1170, and that's a separate product called Qt for MCUs, which is different from the baseline Qt. So if you're looking to develop on the NXP RT1170, the product name is called Qt for MCUs. We will also share the link with you later on.
All right, thank you, Ari. We'll move on to another question here. How do you do the resync of a Qt project when the original scene is in Photoshop and changed? What about conflicts and resolutions at this stage?
Yep, I'll take that one too. This is Ari here. Yeah, that's a very good question. So usually the way that it's done is that it's a one-way import, but because when you're importing a project or when you're importing an asset from Photoshop into Qt, what the Qt Design Studio does is it basically generates code. So you can use something like a code repository, like Git or SVN or whatnot, whichever one you prefer. And you can then, when you re-import a different scene from Photoshop, you can quickly see the difference between the code generated for the first scene as compared to the second one. So that way one can easily see the differences and track what has changed.
All right, thank you, Ari. We'll move on to another question here for you. Is there a reverse bridge, I guess it's VOM Creator to Photoshop?
Right, so there is no reverse bridge from Creator to Photoshop, and the reason for that is Photoshop is simply a tool to create design assets, whereas in Qt Design Studio, which is where you would import the design assets into Qt, what you do in Qt Design Studio is you use these design assets and you create the HMI, you create the user interface. So what Qt Design Studio is doing is it's basically creating QML or basically just creating source code in the backend. So it's basically writing in terms of source code how the user interface would look like. I see that there is, we are using different terminologies over here. So just to be clear what we are talking about, there is a tool called Qt Design Studio, and the Design Studio is a tool where you can import assets from Photoshop into this tool, and this tool is a WYSIWYG. So what you see is what you get, sort of a GUI editor. Then, in addition to Qt Design Studio, we have an IDE that is called Qt Creator, and what Qt Creator does is basically more towards developer focus. So there you can directly edit, modify code, and compile code, etc. So just to confirm that there's Qt Design Studio, which is a WYSIWYG editor, the GUI tool where you can drag and drop and add animations and change the UI. And the other is Qt Creator, which is an IDE where you modify code, or you basically do whatever you want to do in an IDE.
All right. Well, Ari, forgive me if I'm asking a question that you've already answered, but this one asks, does Designer Studio generate QML and form files to be used in Qt Creator?
Yeah, and the answer is yes. So the way that it's envisaged to be used is that you have the Qt Design Studio to import assets from different design creation tools like Photoshop, SketchUp, Figma, and etc. And that you import this into Qt Design Studio. If you want to do modifications using drag and drop tools, you can do over there. or if you want, you can directly modify the code in Qt Creator. So Qt Design Studio, once it does the import, it creates source code, and this source code can then be modified, using Qt Creator. So the answer is yes.
All right, thank you, Ari. Another question came in asking, is it possible to make a working real-world GUI application with Qt for MCUs using only the internal SRAM of the RT1170, and what would be the max practical resolution or color depth?
That's another good question. So, if you look at the SRAM of the RT1170, when we're talking about the EVK, so the evaluation kit, it has got about 2 megs of SRAM. So if we now start calculating the Qt for MCU runtime, which is called Qt Quick Ultralight, it takes roughly about 80 kilobytes. And then you have to add some application logic and most likely some design assets or whatever, if you have assets. Well, assets do not need to be in memory. You can actually put the assets in Flash. It can be loaded directly from the Flash. So what you need to consider is the Qt Quick Ultralight graphics runtime, that's 80 kilobytes, plus whatever application memory you would require. So if you minus that from 2 megabytes, then you get whatever remains is what you can use for the frame buffer. Now, the way that you calculate the frame buffer is you calculate the pixels, so the pixel density, times the color depth. And this is where you would end up, coming with some sort of a resolution that can be supported. So the answer is yes. And the thing is that you need to find out which resolution would be, or which combination of what resolution depth with color would fit within that SRAM.
All right, thank you, Ari. And we have another question here that came in that asks, what maximum display size can the i.MX RT1170 support?
Yeah, this is Philip. I'll take that one. The display size that the i.MX RT1170 can support is the WXGA at 1280 by 800 pixels.
All right, thank you, Phil. And can the i.MX RT1170 be used to run multiple PM-SM BLDC motors similar to the i.MX RT1050?
Yeah, this is Philip again. So yes, we do promote i.MX RT1170 into motor control applications such as PM-SM and BLDC motors. The demo that we created that we've got out on NXP's webpage for the i.MX R1050 runs 4 simultaneous motor control PM-SM FOC motors in parallel, and so there's no hardware differences between the RT1050 and the 1170 as far as the number of PWM channels and ADC. So it shares the same peripheral, so it can do the same.
All right, thank you, Phil. Another question came in here asking, so we can directly import PSD files to the Designer Studio, and Designer Studio will generate code?
That's correct.
All right, thank you, Ari. And we'll move on to another question here. How many Ethernet ports are on the i.MX RT1170 support TSN?
So we've got 3 Ethernet ports on RT1170. One is dedicated for TSN, so it supports one port is a gigabit port for TSN or time-sensitive networking, and then we have a second gigabit port for audio-video bridge traffic, and then we have a third Ethernet port that's 10100 for just general purpose.
All right, thank you, Phil. Qt for MCU needed any OS or RTOS on MCU to run?
All right, so Johan speaking here. I'll take that one. So Qt for MCU does not strictly need any OS. So this is also a difference from regular Qt. So with Qt for MCU, you can also run application on bare metal. So yeah, either an OS or no OS, both are possible.
All right, thank you, Johan. Our next question for you. The RT1170 supports OpenVG and the i.MX8 supports OpenGLES. Will there be any hardware acceleration issues while porting the application?
So I can take that one, I think, as well, because this comes down to, in the end, to the GUI toolkit being used. So at least with Qt, this won't be an issue, and this is actually exactly one of the how Qt makes this easier for you, because when you use the Qt framework and the QML language, this is fully abstracted. So the exact same code, when you run it on the RT1170, it will use VGLite or OpenVG. And when you run that code on the i.MX8, then it will use OpenGL. So there's a full abstraction. You don't need to care really about this. You just design your UI, and it will use what's available on the platform, whichever you choose to use for your product.
All right, thank you, Johan. And we're moving on to another question here. What's the maximum display size that I can run the i.MX RT1170 that will support it?
Yeah, thanks, Chris. That one is pretty easy. That's a WXGA support at 60 frames a second, can support a resolution up to 1280 by 800.
All right, thank you, Phil. And we'll move on to another question. Can the i.MX RT1170 be used to run multiple PMSM and BLDC motors similar to the i.MX RT1050?
Yes, this is Philip again. Yes, it can run all. It has the exact same peripherals that the 1050 the RT1050 has. There's even a really good NXP quad motor control demo where it's running 4 BLDC or actually FOC PMSM motors simultaneously. So with the performance and the flux PWMs and the analog precision timers, you can run 4 at the same time. So yeah, it does the same. It has all the same resources on the 1170.
All right, thank you, Phil. Another question has come in asking, Qt for MCU is free or is it paid for?
All right, so I'll take that one. Qt for MCU, well, as mentioned earlier, there's a free evaluation, but otherwise there's a key difference with regular Qt. So you might know that Qt has a dual licensing model where it's available as open source, but also as a commercial product with additional value. In the case of Qt for MCU, it's a commercial-only product. So the free version is only available for evaluation.
All right, thank you, Johan. And we'll move on to another question here. This one asks, how are i.MX RT MCUs different from other LPC or kinetics and the SoC available in the market?
So the LPC series of microcontrollers in the Kinetis product line are rated for commercial and industrial only, whereas the i.MX RT1170 is the first to go through an automotive qualification. So it does support QM status safety, whereas the Kinetis and LPC do not. However, they are meant to kind of scale. So you can start with an LPC, lower end family or Kinetis, and then scale up when you need more performance and more connectivity. All being inside the same development experience, such as MCU Expresso.
All right, thank you, Phil. So our next question here asks, how many Ethernet ports are on the i.MX RT or i.MX RT1170 and that support TSN?
Yeah. So I said it on one of the slides, and I apologize. I went through that kind of quick as it was bouncing around. But yeah, there's actually 3 Ethernet ports on the RT1170 family. Depending on which version you purchase, there is one version that's the superset that supports a gigabit Ethernet port for TSN. There's a second gigabit Ethernet port that supports AVB or audio-video bridging, but the answer is 1 gigabit port for TSN.
All right, thank you, Phil. And are there Qt Bridge plugins for other tools than Photoshop?
Right, good question. I did not mention that. So yeah, in the demo, I showed you how to use the Qt plugin for Photoshop, but that is not the only design tool we support for export. We also support Figma, as well as Illustrator, and I forgot the name of the last one, but it's a common tool available on Mac. So there are multiple tools available for export. They are all documented in our documentation.
All right, thank you, Johan. And we'll move on to another one here. How can you connect the application logic with the GUI front end?
Right. So in the demo, again, we only really covered the prototyping phase, but in a real application, you'd want, of course, to connect, backend code, application logic, even hardware code into your GUI. So for this, the way it works with Qt, and this, by the way, is essentially an advanced topic which you can see in the training, in the online training we advertised earlier. But you would define interfaces in C++, where you expose all the data you want to show in the GUI, and then these interfaces become available as Qt objects, and they just expose or export all the data you want to export to the GUI.
All right, thank you, Johan. And it looks like we have another question here for you asking, how much RAM and flash does a typical Qt for MCU's application require?
Right, so this one is a bit tricky because, of course, the size of an application will depend on many different aspects, how big it is, how many assets, which fonts do you need, and so on. But we estimate that the minimal requirements for a simple application would be around 80 kilobytes of RAM. And when it comes to flash size, then it would be, again, depends, but around a couple hundreds kilobytes maybe.
And time for one more question here. Is there also a plan to have an import for vector graphics import like Adobe Illustrator to make use of the vector capabilities of the NXP?
Yeah, that's a good question. So the Qt Quick Ultralight in Qt for MCUs already supports vector graphics. So it's a matter of if we have to support Adobe Illustrator, we need to understand how we can, in what format we can capture the data stored in Adobe Illustrator that can then be translated into QML in Qt Design Studio. So I would definitely take that back to the R&D team and ask this question of whether this can be supported. But it's good to know that there's a need for that.
All right, well, thank you, Ari, and thank you, Phil, for a great presentation and Q&A session. We'd like to thank you, our audience, for attending today's webinar, Cost-Optimized HMI and Advanced GUIs for Automotive and Transportation Applications, brought to you by Tech Online and NXP, and this webinar is copyright 2021 by AspenCore. The presentation materials are owned by or copyright by Tech Online and NXP, and the individual speakers are solely responsible for their content and opinions.